Since primary alcohols have two alpha hydrogens, they react twice with chromic acid in an aqueous environment. The first oxidation affords the aldehyde, which is then converted to the hydrate under the acidic conditions used. The hydrate is then oxidized to the carboxylic acid product. The use of anhydrous conditions and the modified Chromium VI reagents PCC or PDC allows the aldehyde to be isolated, since the hydrate cannot form without water being present. Sodium dichromate reacts with aqueous sulfuric acid to give 2 molecules of chromic acid by hydrolysis. One equivalent of this then reacts with the alcohol through a Fischer esterification type process to give a chromate ester. This species is then ready to react to oxidize the alpha carbon and reduce chromium VI to chromium IV. Water serves as a base and an elimination occurs to give the aldehyde. The aldehyde is hydrated and the oxidation process happens again to give the carboxylic acid product. Once chromic acid has been formed, it undergoes a process similar to a Fischer esterification in which the alcohol condenses with chromic acid to yield a chromate ester. Once the chromate ester has been formed, the oxidation step may take place. The chromium is so electron poor that even a base as weak as water is able to deprotonate at the alpha carbon. This results in a pi bond being formed and the chromium breaking off as a leaving group. The electron-poor chromium has now absorbed a pair of electrons and been reduced to the more stable chromium IV. The resulting aldehyde is formed in an acidic aqueous environment, so it reacts with water quickly to give the corresponding hydrate. Since a hydrate is a diol and there is more chromic acid available, a second chromate ester will form. The second chromate ester undergoes the same elimination process as the first, with water behaving as a base. Removal of the second alpha proton and loss of the chromium IV group results in oxidation at carbon and reduction at chromium. This provides the carboxylic acid product. Converting primary alcohols to carboxylic acids is possible using chromic acid in an aqueous environment. The reaction first produces the aldehyde, which is then hydrated. The hydrate undergoes a subsequent oxidation with chromic acid to give the carboxylic acid product. When chromium VI reagents such as PCC or PDC are used in an anhydrous environment, the aldehyde is isolated since the hydrate cannot form without water.